Good morning. My name is Halim Ateş, and I'm a research assistant at Computer Science and Engineering Department. Today, I'm going to talk about the current trends in my research area, which is human-computer interaction, and a specific research on that area. And we all have that touchscreen devices in our pockets, in our bags, everywhere, and they tend to become more popular among people to use for basic tasks like checking emails, taking notes, or social networking, whatever. And also, the research about interaction tends to move to that area, that devices, because there are some issues which needs to be improved, and one of the main issues is the interaction methods. You don't have that variety and speed of interaction like a normal computer on a touchscreen device. For example, you have the keyboard, the shortcuts, hotkeys, or you have the mouse. It has right click, wheel button to scroll up and down. But on a touchscreen device, you only have some predefined gestures like touching, swiping, pinching, or holding your finger on the screen for more options. But it's technically not much different than tapping the screen. So there are some research going on to increase that interface, and some of the approaches uses like extra hardwares on the device or on the user's hand, but they are not very usable. People do not like to wear or put some things on their fingers. So today I'm going to talk about a current research which basically tries to improve the number of gestures on the screen. It's called FingerSense, and basically what it does is it distinguishes between different tools, capacitive tools like a stylus and the finger on the screen, and it also has the ability to distinguish between the different parts of the finger on the screen when you touch it. When you touch it with the tap of your finger, or nail of your finger, or the knuckle of your finger, it can distinguish between these three different touches. So it gives you much more space to increase the ability of user to interact with the device. For example, you can use one of these gestures like knocking on the screen, like a right click of a mouse on a regular computer. So instead of holding your button, or holding your finger on the screen, or touching an extra button, you can just tap with the knuckle of your face, and another option menu pops up. Then you can select another option from there. It's also very good for small smartphones because you do not have much more screen space on that devices. So researchers also tries to minimize the extra buttons or extra stuff to give you much more space. So how it works is it uses the sound signals, segmenting the sound signals produced by the impact of your screen or the device touches the screen. Every time you touch the screen with your finger or another pen, stylus, it produces a sound signal, unique sound signal. So this approach tries to distinguish between these sound signals with using some machine learning algorithms and support vector machine technique. It also can distinguish between different stylus tools if the tip of the tool is made of a different material, like wood, metal, plastic, or something else. So how it can be used is it can be implemented on either tabletop devices like Microsoft Surface, or little smartphones. On bigger surfaces, it can be used for people who wants to work on one document at the same time. You can use different tools, each one of you, and work on the same document at the same time, like a design for an animation or an architectural design. Also, on a smartphone, you can use different tools or different ends of a tool, like a pencil and an eraser at the back of your tool. So you don't have to press one button to change the mode every time. It saves you time, actually. And finger overloading is one of the uses. It can be used like, as I mentioned, knuckle as a right finger, or it can be used like if you double knock the screen anytime, it can open a universal app like a notepad on the screen. So whatever you are doing, you can start taking notes about it and save it without going back to menu, finding the notepad, or opening it, whatever. And also the other possible use is about touchscreen keyboards. You know, touchscreen keyboards also another main issue about these devices. It doesn't have the speed of a normal keyboard, and because you don't have a haptic feedback on the screen, and also the keys are more not much bigger as a normal keyboard. So you can use a different touch, like a function key of a normal keyboard. So when you press it normally, it writes letters to screen. But when you press it like nail of your finger, it can write another special character or a number to screen. So you don't have to switch between keyboards or different languages or whatever. And there are many more possible approaches, uses of this approach. It's pretty much similar to what we are trying to do at our lab. So I want to talk to you about this today. Thank you for your time. Any questions?
So is your actual research in the detection of the different human interfaces with the screen?
Yeah.
Software?
Yeah, the software. Actually, it's not our research, but in this research, they are trying to distinguish between fingers with software. Actually, they are using the microphone instead of the inside the device. But I think they only can do it on an Android phone because they need to access the raw data. On most of the smartphones, they have some mechanisms to reduce the noise. So they have to access the raw data, and they can do it on Android phone.
Would this help, like, with with transmission of disease? Because if you tap something with your
Yeah.
your knuckle, you're much less likely to transmit disease. I've heard that cell phones are like
Hmm.
the dirtiest things that exist as far as germs go.
Yeah, but smartphones are generally for personal use. They are not used by everyone around you. So I don't know. And yeah, I'm not very aware of that topic. I don't know. Thank you.
That was 8:40.
Oops.